This is the answer for homework 8, question 1. So the question gives us that the mean of x of t is equal to eta. I think that n is that Greek symbol, and that's because we're also given that x of t is a wide sense stationary. And we're also given that the autocorrelation of t1, t2 is equal to r of x of tau, where tau is t1 minus t2. And we also know that the in a wide sense stationary situation, the autocorrelation was only reliant on t1 and t2. And we're also given the function y of t is equal to x prime of t. So the first part of the question asks us to find the mean of y of t. And that's equal to the expectation of x prime of t. And we know that x prime of t has to be 0 because x of t is a constant. So the answer for the first one is 0. Then the second part of the question asks us to find the e of x of t times y of t. And so we're given that y of t is equal to x prime of t, so this is just equal to e of x of t times x prime of t. And that's also equal to, I expanded it a little bit more, so that's e of x of t times e of x prime of t, which is 0 because we know that e of x prime of t is equal to 0 from the previous question. And the next part C, asks us if x of t and y of t are uncorrelated. So we know from a few lectures back, that if e of x of y is equal to e of x times e of y, then x and y will be uncorrelated. So e of x of t times y of t is equal to 0 because we just calculated that in part B here. And if e of x of t and e of y of t is equal to 0, we also know that e of y of t is e of x prime of t, which is 0. So that's also just going to give us e of x of t times 0. And so both e of x of t times y of t and e of x of t times e of y of t are 0, which means that x of t and y of t are uncorrelated. And then the last part of the question asks us if x of t and y of t are orthogonal. So the textbook says if e of x, y is 0, then x and y are orthogonal. And so from part B, where we calculated e of x of t times y of t, we know that that's true, so e of x of t times y of t is 0, which means that x and y are orthogonal. And some other properties of wide sense stationary functions. Some other properties of wide sense stationary processes are that it's a stochastic process, which means that it's random. The mean of the process is constant, so it's not dependent on any variables, specifically t. We know that e of x of t squared is equal to the autocorrelation of 0, and that is equivalent to the average power. So it's basically, another way to say it is that the average power is equal to the autocorrelation of 0. And we also know that the autocovariance depends only on tau equals t1 minus t2, similar to the autocorrelation.